And here I will be covering the one more aspect of the laminar pipe flow, and that's important actually. And this is about the like we solved the two cases with quarter model, half model, and we use the symmetry condition. Now question is that if I use the product condition, and product condition is used when we cannot represent model like in a sense that symmetric means that it's it's a mirror copy. So for example, if I have this circular cylinder, so what I can do is that here I can actually use these walls, these boundaries as a symmetry. So if I reflect this part will be like exactly will be copy of this part. So this will be reflected here, and this part will be made. And when I have the symmetry on the bottom side, so this will reflect this whole thing, and I will get the complete circular cylinder. Okay, this front part of the your cylinder, and definitely in 3D you will get a complete cylinder. So this is the thing here. Okay, so now what I'm doing is that I am taking the only 30-degree sector. Okay, and I will use the periodic condition here and here. So what does the periodic mean? Periodic is slightly different than the symmetry. Symmetry means that this will reflect the model, like a copy the mirror the model on the other side. Okay, and so in the case of periodic case, periodic means that here if I'm applying periodicity here, so the second copy will be here. Okay, exactly same thing here, and but provided that the flow is also periodic, means that the flow is not changing along the angular coordinates or theta direction. So in this case, what does it mean? It means that the flow here, here, will be exactly same over here. Then the flow here will be exactly same on the here. But in the case of symmetry, the flow here, conditions here and condition here exactly same, and conditions here and conditions here are exactly same. So this is a difference between the periodicity and symmetry. So periodicity is only applied when we have the like a rotational, if we can, I can rotate the model, I can get the same geometry again or the same flow again. It's only possible then. For example, if I have the square, like a rectangle geometry here, okay, rectangular pipe or whatever it is, in this case, I can only apply the symmetry on these two boundaries. Like I can make the model one fourth of the geometry, whole geometry, 1/4. But I couldn't make the periodic here because this is not a, if I rotate this geometry, I could not get the same geometry here. So in the rotation, this will be different thing now. But this rotation only possible when the boundaries are circular. Okay, circular geometry can have the periodicity. Okay, so I am taking the benefit of the circular geometry here, and I'm going to model the 30-degree sector, and I will see that do we get the same results or not. Okay, and second thing is that I will make the mesh with the help of the two methods. One is the triangular. Why so? Because triangular mesh will be easy to use, but I will use the extra command here, and that is called the mesh control. So mesh control will actually make the mesh periodic on the two sides of the mesh control means it will make the mesh periodic and are symmetric, so both will work very well. Okay, so it means that the number of cells will be exactly same on the both sides of the meshes here, on the two sides of the symmetry or periodic condition. So for periodicity, when we are, and this is important when you are using triangular mesh, because triangular mesh we cannot control the mesh ourselves. So it will ensure that the number of cells on the each location, they are exactly same, and location is exactly same on the each and every direction and each and every location here ideally. So mesh control is the one thing that we will learn, new thing. And the third thing that we will learn is that we will use the in case of periodicity, not in case of symmetry. In case of symmetry, we just directly provide the symmetry conditions. In case of the periodicity, we have to make these two boundaries periodic. Okay. So right now we are solving with the help of the periodicity condition. Only thing is that one is the triangular mesh, one is the hexa meshing with the sweep meshing method. But we should be having the extra things there. The division of the geometry is important. So we have to use the make periodic command, text command in the Fluent. Okay. Then the rest of the things will be almost similar. Okay. Post-processing may be slightly different because the geometry now is only one sector, like a 30-degree sector is here. So we will see this thing as well. Okay. So let's go there. Okay, so let's start here. Okay, so the first case, that is the 30 degrees periodic tetra meshing. Let me show. I will explain only things which are important, because you know very well how to make geometry and the meshing. Okay. So only thing that I've applied here are three things here: symmetry and periodic condition and periodic condition. Okay. So let me explain. There is from the tools menu you can apply the symmetry condition, but be careful about the one thing, that you should not be exporting the symmetry. Okay. So I'm using symmetry actually to make the model, to make the one portion of the model, like that is 30 degrees model. So what I did is that, before I explain this thing, so in the symmetry what you have to do is that I'm selecting the plane number 4, and plane number 4 is created some location that is making the sector cut of the 30 degrees, and second plane that I use is the ZX plane. Okay. So ZX plane is exactly here, and second plane that I'm going to make is over here. So I think you get the idea that if I have the ZX plane here, that will cut the geometry in this way, and second plane that I use in symmetry condition is over here. So it's a 30 degrees difference. Okay. So how this plane is created, let me explain that thing also. So select these two number of planes to the 2, and then choose these two planes, but choose the first plane number 4 and then the ZX plane. Okay, this is very important. If you choose ZX plane first and then the VLAN plane number 4, you will get something different geometry sector. Okay. So let me explain how the plane number 4 is created. This is made from the ZX plane, and I made the 30 degrees sector, but it was making instead of 30 degrees sector I wanted to make, it was making 120 degree sector. So I just reversed the axis so that it was going on the other side, then it gone on the other side, and I was able to get 30 degree sector over there. And then I have defined the two more boundary conditions, like we did in the previous case. We defined the symmetry conditions here, so I defined the periodic conditions, periodic 1, periodic 2. That's all. Okay. So I don't think so that I should be explaining the things in a detail here. So once you see the file and you practice yourself, you will get the idea. Okay. So now let me close and open the mesh file. Okay. The mesh file here is it's a very simple mesh file. It's a tetra meshing. I define the sizes on the periodic surfaces and also on the inlet outlet. The top wall is going to get the meshing from the size function. So let me show you. And one more thing is that there should be no connections here. No interfaces should be there. So just delete the contacts directly from here. Instead of deleting the H in every contact, directly go to the contacts and delete the contacts in the connection directly from there. Okay. Okay. In the mesh, what I did is that I use a page confirming method. Okay. Because this is most easiest method to make the mesh, and still we can get the high quality mesh with the prism elements or the inflation layers in the boundary layer. I use a face meshing on the periodic, and this time I use a 0.05 size. And on the inlet outlet, I use a size of 0.03. And on the inflation, I put only 5 layers for the demonstration purpose. You can go for the even 15 to 20 layers. The most important thing is that I have added the mesh control. Mesh control is needed actually when you are going to make the periodic mesh. So this will ensure, and especially in the tetra meshing, so this will ensure that the mesh will be having the 1:1 correspondence on the both sides. Okay. So here you can see that how mesh will look like. And problem with the tetra meshing is always the same. The sizes, the number of cells will increase dramatically. Okay. So even though I try to put the sizes compatible, but definitely you cannot have the very few cells there. They cannot represent the flow on the boundaries. So I have to have some cells there. And number of cells, you will be surprised to see. Elements are to 53,000, same as a 3D mesh. So this is a problem with the 2D mesh, and especially when we are getting the triangular mesh. When if you go for the hexa meshing, number of cells will reduce with substantial quantities there. Okay, still we have to make some cells there to represent the geometry and the flow properly. But that's like a very I would say maybe it's a 1/10 of the mesh size of this one. Okay. So anyhow, so we use the mesh control and we use the face sizing and smaller size this time for because the geometry is smaller, so we have to represent geometry properly. So we have to have the max small size here. Okay, then simply click on update. In this step, I will show you the completely. So I will reset the fluent part and I will start from the scratch so that I can show you the different commands here, because putting the boundary conditions and the material properties are very simple. There are only 2 or 3 things to be put there. Laminar flow, material properties, the boundary condition like a velocity inlet. The main and important thing is the periodicity in the mesh that has to be done. Okay. So here is the mesh file. Okay, let's check the mesh in the Fluent, and here we have the a very nice mesh actually. So this is not required. Actually, we cannot have the less than these cells. Okay, inlet is okay, outlet is okay, wall is okay, and inflation is okay. So and if you take a look on the quality, 0.2 minimum optimum quality is a 0.2, aspect ratio is 17. That's very good actually. Okay. But I would recommend one thing, that this mesh is not final mesh. You have to create 2 or 3 more meshes. Maybe one is on the coarser side and one on the finer side, and check the results that if they are giving you measurement results, then you can go with the mesh with a less number of cells. Okay, so be careful about this thing. This is just for demonstration purpose, that how we can apply the periodic conditions. Okay, so here click on type the mesh, then you can press enter key and you will get the number of commands that are available inside that command. Okay, so here I will use the modify zones, and second thing is that if you type a few letters, and please be careful that those 4 letters or 3 letters, at least 4 letters are required, should not be contorting with some other command. So if that command also has the same first 4 letters, then you will not be able to get that command there. Okay, so now modify zones has 4 letters and it is not having the same letters with some other commands. So I can only write down the 4 letters here. Okay, then press enter key. You can see there are the 2 commands. The old command is make periodic, and the new command is create periodic interface. So this option is available yet. So we will use the new command. Okay, so that is the create periodic interface. You can copy this one, or you can simply type few letters here. So I think that the create command is also repeated here, but if I put the hyphen symbol and then only a 1 letter periodic, and this will work very well. Okay, so you want to create the auto, conformal or non-conformal, and I will go with the auto. Otherwise you have to type that name here, and this will change that type to that type. So there are 3 options. Auto is by default, so I will simply press enter key. The zone name that you want to put there is, let's say I want to put the periodic, but definitely then after that you have to change the name as well. Okay, and now go to the boundary conditions here. So either you can put the ID here, or you can put the name. If the name is difficult to you can copy paste the name, or you can directly put the ID. So let's put the name here, periodic 1. Second is the periodic 2. Okay, and the spelling should be correctly written there. You want to make the rotational periodic. If no, then it will be transitional. If yes, then it will be rotationally periodic. Yes. Origin, axis origin is 0, 0, 0. Yes, it is 0, 0, 0. So just enter. Axis is along the Z axis, correct. And auto detect offset. Offset is 30 degrees here. So this will be, you can directly give yourself. If it is not picking up, then you can give it manually. So type no, and it will give you option to input the value for the offset. Otherwise, just go with the auto options. Then yes. Okay, so we have successfully created the periodic boundary condition with the offset of minus 30 degrees. So it doesn't matter actually. The 30 degrees is a requirement, and this has created the conformal periodic boundary. Why conformal? Because we use a mesh control. So both sides have the same mesh. Exactly same mesh means that the even exact location, every location, number of cells, like they are exactly same. If they are not same, then the fluent will create the non-conformal periodic boundary. Okay. So now you can display, and but definitely you need to change the name of the second periodic condition to the let's put it periodic 1. Okay, and apply and close. This is like you can see this is rotational periodic. You can change it to transitional as well. Okay, if you display the now these boundaries, the default color will be the green color. This signifies that the periodic boundaries are now enabled properly. And we do have the these inflation layers and very nice mesh on the inlet and outlet. Okay. Okay, now let's go to the models, and from here change the model to the laminar. Okay, and then go to the material properties. So we have to change it to the this is for the original case of the 40-meter length and the 1-meter diameter. For that the value of viscosity is 0.01. If not, you are not confirmed, then you can confirm from here. Okay, 0.01 Pascal second or 0.01 kilogram per meter second. So click on change create. And next thing is the boundary condition, where we are going to be displaying put the values for the velocity inlet. So only thing that we need to put here is the 1 meter per second for the velocity at the inlet. Apply and close. Okay, in the methods I will choose simple, and I will make one more thing here, one point here, and that point will be at the 0x, y0, and the z will be 35 meters, and snap on probe click is off, and click on create. Now right click on the report definitions and new and surface report and vertex average, and we are going to monitor the velocity on this point, and let's say this is the velocity monitor at point 35 meters z. Okay, and you can also print to console and then click on OK. So confirm everything is all right. Okay, in the result plot I'm going to not check the any convergence here. This will run for number of iterations or when I stop that one. Okay, you can click on OK. Initialize from the hybrid method or from the inlet, that's your choice. And after that you have to run the case for with a simple method. With a coupled you have to use a less iteration, but with the simple method at least 1000 iterations, and then click on calculate. Okay, now the case is running. Okay, the solution is now complete, and I will check the results afterwards, but you can have a idea about the results by plotting the pressure plot. Okay, and if you want to show the complete geometry, go to the views, and in the views you have to click on the define. Here is the option about the periodicity. Okay, this option is here. So click on the periodic 1, periodic 2, and it's rotational, and origin is at the 0, 0, 0, and axis direction is a plus z direction. Angle is -30 and number of repeats are 12, definitely. So click on display. And I think you know that in the case of the CFD post, you have to click on the instance transform, and then you have to use a periodic or rotational periodicity. There's option there. Okay, we will check the results afterwards once we run the second case also, and then we will compare the full cylinder, which is here. Medium mesh sweep. Second is with the periodicity but with the tetra meshing, and the third one is the periodicity with hexa meshing. So the third case is 30 degrees periodic, and it's a hexa mesh. Okay, I will give you the briefly idea about the geometry creation here. So the geometry creation requires some decomposition. So I have to decompose geometry. So you can see here, number one thing is that I have clicked on the rotate, and I actually put the rotate command, body transformation and rotate. So what I did is that initially geometry was at the like the plane we were cutting here was along the x-axis. So geometry looked like it was on the x-axis and then some angle there. Okay. So if I don't use this command, like suppress everything there, geometry was here. This is what this is what I'm talking about. So this is along the zx plane, one side, and then we have the angle here. Okay. So like if you display from xy plane, this will look like in this way. This thing. Okay. So I just like rotate it by 75 degrees so that it goes on the middle of the 15 degrees on the right side of the y-axis and 15 degrees on the left side of the y-axis. Okay. So that when I apply the operation, this will be much easier for me to draw the geometry for decomposition of the geometry of the circular cylinder with a 30 degree sector. So unsuppress, this is where I have placed this one. Okay. But just be careful that when you are defining the axis direction, the direction should be correctly defined. It should go on the plus y-axis. Okay. And angle should be correctly done. And then what I did is that I made the two more sketches on the xy plane. Okay. The one sketch is at the I tried different angles. I started with the 50 degrees angle from y-axis of the one line, and then I made the constraint here. And that constraint is a symmetric constraint which I applied on these two lines. The symmetric constraint or symmetry constraint. So this line and this line will be having same angles. So there's no need to define the dimension like angle for the both of the lines, but for only one line, and then put the constraint for the symmetric boundary condition. And also I defined the height of this point from the x-axis. Okay. And the angle I found that if I use the 50 degrees, 45 degrees, so this will not produce a good mesh because the sector size is 30 degrees. So on the both sides are 30 degrees. So 30 degrees angle will produce the best results, best mesh. So that's why 30 angle is given there. Okay, finally. And then I use the first extrude command. And in the first extrude command, what happened is that this should be closed sketch. So this should be a closed geometry, and please note that the sketch number 6 is different. That is over here. So I can hide it. And now you can see this sketch is over here. Okay, this sketch. So it should be closed sketch. And then in the extrude command, what I did is that I used the slice material and I made a length of 50 meters so that it will cross whole geometry. So slice material and through the whole geometry of the circular cylinder. So this will make this body on the bottom side, this body, and one body will remain here. Okay. Okay. Then I made the another sketch, and that will take the first point from this point onwards. Then I made the one vertical line, exactly vertical line. It should be passing through the center of your geometry. And then I made another line. This angle is not an important part. Okay. So I made another line going in this way. And then I made another line, and that line actually was going through the same angle as angle of the sketch number 5. So on this side, okay, same angle, and it should go outside. And then I joined this line and this line with a straight line. So what the dimension of these lines or angle of these lines is not important. It should be outside. That's important. Here this line and this line, they should be exactly on. So either you can put the angle here with the y-axis, or you can just align with the line over here, and this line is vertical line. Okay. So again I use the extrude command with the same option like slice material, 50 meter length, and that's all. So this will actually you might be wondering that this will subtract the only one body. So definitely it gets you the one slice here. So remaining will be third slice. Okay, this is the point. So now you have the 3 bodies. Okay. The last thing is that because the symmetry, like a periodic condition was already there, and so here these conditions, symmetry and after symmetry we have periodicity applied. So this is still there. Symmetry is like a not for symmetry, but symmetry is a command. If you export symmetry, then it will export symmetry commands like export symmetry surfaces. But if not, then it will only export this sector geometry to the Ansys meshing or some other meshing software. So then I have to subtract these geometries into multiple parts. And then finally from the multiple bodies, I have to form a new part. Okay, so I selected these 3 parts, right click here and I form a new part. Okay, so this is same as we did in the case of sweep meshing. So from the 5 bodies, we made the 1 part. Okay. After that, I have gone through the meshing. Okay, so you have to click on the green tick mark and close it. Okay, this is the geometry we have here. Okay, so what I did is that I changed the method to the sweep meshing because I copied the tetra meshing method, that container, and the edge sizing I put are like similar to the 3D case, 50 cells along the length. Okay. It is a hard, behavior is a hard, and edge sizing second, this is important. So this here, I put the number of cells 7, although by sector size, because in the 360 degrees, we have the 40 cells. So if I divide the 360 degrees by the 40, I should be having like 9 cells then. Okay. So no, sorry, for 10 degrees, the 90 degrees, for 10 cells for 90 degrees. So for 30 degrees, it should be like 3 cells or 4 cells. But then 4 cells will not be enough. So I put the 7 and 7. So this will be the like 14 divisions. Okay. And same goes over here because this mesh will go on this edge and then here. And on the right side, this will go on this edge and then go on the opposite side. And then edge sizing here, this will be for diagonal edges. Here I put the 20 cells. And the behavior is hard and biasing factor is 3 and 3 reverse biasing are applied. Okay. And if you generate the mesh, number of cells are very, very less, like a 17,000 to 20,000. It's 16,450 elements are there only. Okay. And this is like because of the control we have in the Hexa meshing, especially on the lateral direction, lengthwise direction. So we could control the cells here, and it's not important to have the very fine mesh here. But tetra meshing, if I reduce the size and along the second dimension, like here, it will also reduce the mesh, mesh elements, and mesh elements will be very, very big, and it will not represent geometry in a proper way. So that we couldn't do. Okay. So here, the quality is also very good. The minimum orthogonal quality is a 0.5. And the maximum is a 0.99987, average is a 0.87, that's a very good. And last thing is to update the mesh. Okay, and one more thing is that in the connections, there will be contacts. Please right click, not go to the like a subset, like every contact here, region here, but right click on the contacts and then delete it. Okay, very simple solution. Okay, so you can save the project file here. And then go to the setup. So we will do the same thing here, like we will be making here we don't need the mesh control because although I could use that mesh control if needed, you can use it. But here, because in the Hexa meshing, we have the exactly control on the sizing and everything ourselves. So whatever size we defined here, same size was also on the other side. So there's no need of to use the mesh control. And mesh control, I think, is a good option if required. Okay, here we don't require it, so I'm not using it. Okay, so go to the setup. Okay, so report quality is very good actually. Aspect ratio is 140, and here you should go to recorded mesh operations and solve any issue that is there. I don't think so we have any issue. Display the mesh and then we can check. Okay, so use by the surface type. Okay, so here they are the like a product. They should be product, but right now they are walls. So I will use a mesh and modify zones, and it is the command is the it's create periodic. Okay, so create, yes, auto. The zone name is like you can put any name, let's say periodic. Zone periodic name is a periodic 1, and the periodic 2. Yes, it's a rotationally periodic, and the origin is 0. Same thing. Press enter, press enter, press enter. Okay. So go to the boundary conditions, and from boundary conditions change the name to the periodic 1. Okay, now display mesh and use the default colors. Okay. So here, okay, you can also display with the faces. This is a mesh we have for the Hexa case. Okay, you can see this is a very nice mesh actually, and gradually increasing size on the top. So maybe you have to consider to increase like decrease the first cell height. So maybe you need to run the multiple meshes to ensure that we have the mesh independent results. Okay, so the number of cells are 16,450 cells are there. You can check the mesh. If we didn't define the periodicity, then you would be getting the error. But here are the warning actually. So we have the domain extent, we have the minimum volume. It should not be negative. Okay, it cannot be 0. It cannot be negative. So if the negative is here, then you have to go back to meshing software and correct the problem. And periodicity is like on the 2 zones, and angle is 30 degrees. Okay, and axes are the Z axis, and the origin is 0, 0, 0. Okay. So in the models we have the laminar flow, and in the materials we have the properties defined very well. In the boundary conditions, based on the zone type, inlet should have the inlet boundary condition, and periodicity are defined here. Wall is a wall here. Okay, in the methods, we should have the simple method. In the monitors, I am not monitoring any convergence here. I want to move it freely. And once the solution has converged properly, which I feel it is converged, then I will stop there, and or when I want to stop myself. Okay. So either I stop myself or number of iterations are done. Make a 1 point here. Okay, report definitions. Okay, you can initialize solution, or the solver can initialize by itself. This is the old plot that is giving us the wrong results actually, and this is the new one that is giving us the correct results. So we have to see the both residuals and this point data for the velocity at the 35 meters location. We have the stability issue, but now it is gone. Okay. What was the a warning there? Okay, we have the simple, yes, we have the simple, but still it was giving us some problems here. So let's check the results. Then I will continue actually for the 1000 iterations. With the simple method, you have to run the for more iterations. Okay, and product is instancing, and it's a product 1 and 2. Okay, now keep on solving the case. Okay, Okay, now solution is converged, so we can stop here. Okay. Some issues are there. There is like another method that is coupled, but in the coupled, let me try with the off method in the pseudo time method. Okay. And default is a 200. So let's try this method also. Okay. So calculate. So it is giving us some better results also. Okay. So maybe you can try you can try the coupled with not with a global time, like a time method. So make it off, and then in the controls you can go from 200 to the around 2 million. Okay. So let's make it at least 2000 is needed. Okay. So you can try with the 2000. If not, then you can go back to the 200. So this is the I used to use that method in the past, and this is the best method actually for converging solution. Okay, try this one. Okay, so now we can stop here, and velocity has converged to the 1.990. That's a 2 meter per second, and this confirms that the maximum velocity is twice the average velocity or the inlet velocity, that is 2 meter per second. Now 1 into 2 is the 2 meter per second. Okay, so now you can save the project file. Okay, we will do the post processing in the CFD post. Okay. Okay, make the connection from solution cell to the results. So this is the between the three cases, the full model 3 degrees periodic tetra meshing and 330 degrees periodic hexa meshing. So double click here. Only problem that I will be facing is actually with location of the tetra meshing, because this location is on the along the x-axis. So what I suggest is that if I go to solution and rotate geometry by the 75 degrees in the along the z direction, so both periodic cases, hexa meshing, tetra meshing, they will be exactly on the same location. And then when we draw the vertical line, that line will be still valid. Okay, so let's do it. Okay, go to the view menu, and from here click on the periodic instancing, and what I want here is that I want to clear the repeats. Okay, now display the mesh. Okay, this will give you the now the same a one sector geometry. Okay, so this is along the x-axis. So if I align with the x-axis, this is what I'm going to get here. Okay. Okay, so in the domain we have the transform command. So it's rotate. And if I rotate it along the positive z-axis, so this will go on the it will go where? It will go on the on the top side, right? So I can make it along the z-axis 1, and angle is a 75 degrees. Okay, let's try this thing. Okay, so rotate and display the mesh. And this is along the y-axis. Okay, along the y-axis, and okay, this is done now correctly. Okay, this is what we wanted here. Okay, take a look on this case. This is also along the y-axis. Okay. Okay, now let's open the this hexa meshing case as well. So I want to just see the mesh extents. So from mesh extent, actually you can get the idea. Okay. So we have the z-axis is 0.40, y-axis is the 0 plus 0.5, and x-axis is the minus 0.125 to plus 0.125. So let me just confirm this thing from here as well. So it's the same thing here. Okay, so now I think we can go ahead. Okay, One more thing is that I want to run this case also with the help of pseudo time step, okay, with the coupled solver. And the pseudo time step method should be off, and in the controls, let's first try with 200. Okay, let's try again. I think that we have some validation issue, so let's try to solve that issue. Okay, so it is from the report monitor. Okay, so I think this will not change things here much, so we can stop here. Okay, so I use the methods as coupled with the pseudo time method off, and controls having 2000 flow current number, and that's all. Okay, so here you can save a project file and double click on results to open the new results files here. Okay. Okay, so I just right click here and I copy camera from the view number 1. Okay, and secondly, you can display the wireframe, uncheck and then check again. Alright, so you can also hide the inlet and the outlet faces. Okay, so right click here and use a second view from the and this is already explained in the some of the videos. Okay. And view number 3. Okay, here I will work on the size of the symbol here. Okay. Looks like it's a more finer mesh in the other two cases. Okay, so the point 1. Okay, anyhow, so let's display the plot for center line velocity. So only tetra meshing has the issue. Both of hexa meshing with the product like 30 degree sector and the full 360 degrees model, they have the same results. And centerline pressure is exactly same. The area velocity profile is they are like showing you the half values for the 90 degree sector. They will show you because only half model is available there. Okay, so they are giving you the data like this, but they are matching very well. Tetra meshing has some issues there. And in the table number 1, do we have the data here? Yes, it's the same thing. It's almost same if I have the scientific digits to the second order accuracy. So they are exactly having the same data. Okay. So only in the case of the tetra meshing is slightly higher value, but they are almost giving us the same results. Okay. So it means that the 30 degree sector, even with the tetra meshing, although hexa meshing has a more finer mesh, they are giving us same results. Okay. And what about the coefficient of friction? So this is also okay. Only thing is that in case of these two cases, in tetra meshing, it is starting from the very high values 3.3. Okay, 3.33. But in case of the hexa meshing, both hexa meshing, it is starting from the around 0.4, and then it settled down to the value of 0.16. Okay, 0.16. So let's change a scale here for the y-axis, and it's like a fixed one. Apply, and range is like from 0 to the 0.2. Okay, so let's make the like a division, like a, that is like let's make it 0.18. Okay, so you can see this is like a giving data at the point 16 here. Okay, tetra meshing is like showing the wiggles in the solution. That is the problem of the tetra meshing, because the cells are not exactly on the same location as the where the line is, but the both of the hexa meshing, they are giving you very excellent results. Okay, so with this workshop is now ended. Okay, so we covered a lot of things in this workshop. I hope this will help you a lot. Thank you very much.